Today we're talking about multiplying and dividing real numbers. The identity property of multiplication states that for every real number n, 1 times n would equal n. In other words, multiplying 1 times a number equals that number. So 1 times 5 equals 5, and 1 times negative 5 equals negative 5. The multiplication property of 0 states that for every real number n, n times 0 equals 0. In other words, multiplying any number times 0 equals 0. 35 times 0 equals 0, negative 35 times 0 equals 0. The multiplication property of negative 1 states that for every real number n times negative 1 equals negative n. In other words, if you're multiplying negative 1 times a positive number will equal a negative number. If you're multiplying negative 1 times a negative number equals a positive number. Now, why would this make sense? Well, because the rule for multiplying integers states that when you're multiplying two positives, for example 5 times 2, it equals a positive. When you're multiplying two negatives, it also equals a positive. But when you're multiplying a positive and a negative, it equals a negative number. Five times 2 would also equal negative 10. And we can use Mr. Dorito to remind us of this rule. A negative times a negative equals a positive. A negative times a positive equals a negative. Let's try a few examples. Negative 9 times negative 4, will it be positive or negative?
Positive.
Positive. 36. What if we're multiplying 5 times negative 2/3? Will my answer be positive or negative?
Negative.
Negative. Now if we're multiplying this, we can change 5 to an improper fraction, times negative 2 over 3. 5 times negative 2, negative 10, and 3 times 1 is 3. Can I simplify this? I cannot simplify it. I can change it to a mixed number, and that would be negative 3 and 1/3. They mean the same thing. If we're multiplying negative 10 times negative 5, positive or negative? Positive. If we have to evaluate negative 2 times x times y, where x is negative 20 and y is negative 3, the first thing we have to do is substitute. X is negative 20, y is negative 3. Does it matter what order we multiply in? No. So let's start multiplying. Negative 2 times negative 20 is positive 40. Positive 40 times negative 3 is negative 120. A positive times a negative is a negative. Right? For example, if we have to simplify these expressions, if we have negative 3 to the 4th power, let's look at this. This exponent 4 belongs to the base 3, not the negative. This means negative times 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. This means negative 81. Bring down this negative right here. Negative times 9 times 9, negative 81. Let's look at this one over here. Negative 3 to the 4th power. Because negative 3 is in parentheses, this means negative 3 times negative 3 times negative 3 times negative 3. Now negative 3 times negative 3 equals positive 9. Negative 3 times negative 3 is positive 9. That means 81. If we're dividing integers, we use the same rules as we do for multiplying integers. That means that if we're dividing a positive by a positive, our answer will be a positive. If we're dividing a negative divided by a negative, our answer will be a positive. Because when we're dividing two negatives, our answer is positive. Pretend you're covering the two negative signs. If we are dividing a positive divided by a negative, it will equal a negative. If we are dividing a negative by a positive, it will equal a negative. Now these are exactly the same rules as for multiplication. If we have to evaluate x divided by y, the first thing we have to do is substitute for our variables. This means negative 3/4 divided by negative 5/2. When we're dividing fractions, what do we have to do? We have to multiply times the reciprocal, that means times negative 2/5. Doesn't matter that I kept the negative with the numerator. Doesn't matter. Now we can multiply across. Negative 3 times negative 2, 6, and 4 times 5, 20. Can I simplify this? 3/10.